Okay, there we go. Alright, so I had to switch my audio device again. Alright, so we're live now, and as you can see, we have a new window. Um, so I don't think I'm going to be doing this very often, but I've been putting this off for way too long. So we're going to have to let's edit some of these sprites real quick, just so that we've got something better than this little derpy little penguin right here. Uh, I mean, it doesn't look bad, but it doesn't at all match what Snowball looks like or what the other guys look like. So let me just get a Snowball for reference. So this is Snowball, and I mean, that's about it, I guess. Um, so he's 64 by 64. This guy's 51 by 64. We could just shrink that down to 48 by 64, because it's better numerically speaking. They're multiples of 12. I don't know. It really doesn't matter. But anyway, so I guess, see, here's some issues. Like, you can see the transparent pixels right there. Like, I'm by no means a pixel artist, although I have done pixel art because I had to. I have had to because, well, in the past, let's say, because I've got some people right now who are pretty good at it themselves, and they're helping me out with this. But I am no stranger to doing this kind of stuff, basically. Um, so we need to think about perspective for a little bit. And maybe this is going to be the, well, I don't know. I don't want to draw the whole time. So let's just do something really quick. Just we have a level to get to, and I have ideas for that level for once. So there we go. Can give him some eyes, I guess. Gosh, what do penguins even look like? I have I have pictures of penguins all over my bedroom. I know this is a little, maybe a little TMI, but I've always liked penguins, and I have a lot of pictures of penguins, so think about that what you will. I don't know. Uh, okay, here's a classic image of a penguin. Right? Everybody knows this picture. So we've got some yellow, and we got some orange. Okay. Man. Interesting. So it's not just a round little circle, it's like, yeah, it's like a suit, like a tuxedo. Now we know why they're called that sometimes. Right? So it kind of looks like that, and then it's weird that they have that yellow right before the top, like that. That doesn't look too bad. And what else do they have? Yeah, like that. I don't know. I'd like this. I don't know if this is that much better, but it's something, I guess. Uh, the real issue, like, the real issue is that this guy's pitch black right now, and I don't think that's a good idea. Let's make him, like, really dark blue. Like, I don't want to borrow too much from Mario, but I know that they have dark blue penguins, so that can't be that bad of an idea. Like, they knew something. They were doing something right. Oh, man. Suddenly, Paint.net is lagging like crazy. Um, so, I don't know what the deal was with that. Hopefully, it's not because I'm streaming. But it probably is. It's probably what it's doing. Anyway. Uh, That's very black. It's a very black blue. Well, the outline for Snowball is blue, and Krampus doesn't have an outline, so... Or maybe I should do this the other way, where the inner is black, but the outline on the outside is blue. Like, maybe that makes more sense. It's a little strange, I guess, but maybe. Oh, we also need to tick that anti-aliasing box. Can't remember if it's on or off, but basically we don't want there to be those semi-transparent pixels. This is not an art stream, but I don't know how to shade, if we're being honest with ourselves here. So if anybody has suggestions, throw them out. This is how I draw. Maybe we can make this a bit lighter, I don't know. Yeah, that's better. Now I can actually see the outline. But now he's too blue. What if there's like, I don't know. What if there's gray instead? Should be gray. Gray doesn't look too bad. Well, I think one issue is that his beak is kind of at an angle, which doesn't make any sense, because Snowball is definitely not at an angle. So let's fix that. Okay, so now it's more like he's facing the right way, I guess. But these guys' beaks they're actually black. They have that on the side, but they're actually black on the top, which is interesting. So maybe we need a little bit of that. Yeah, maybe. Maybe that's okay. See, the problem is he's got to be pitch black on the inside, but if we make it too, like, I don't know, maybe, okay, well, maybe an outline's a bad idea. Maybe we just need to shade certain parts of him. So let's grab his feet and make them kind of like that and like that. And we're going to edit his feet so they look a little bit like they're standing the right way. Well, okay, penguins' feet are like really close together. So we need to change that, I think. Probably what we should do is just start over with the feet. Make them more square, possibly. like that, then like that, and then just duplicate it like that. There we go. Now we got feet. We can just drag the feet up and do that maybe. Are their feet actually yellow though? These guys' feet's not yellow. I don't know. I don't know what kind of penguin this is supposed to be. Maybe it's not an emperor. I don't know. Like I said, as a kid, I did intense research on penguins, but now I can't remember anything about them. So that's no good. Okay, his wings or whatever shouldn't be extended that far out. Unless he's like actively waddling, I guess. But we're gonna need to add some sort of outline to show that his wings are like close to him. So that, do that. Okay, that doesn't look too bad. And then, yeah, that's still too close. And there's still some blue left over there. Oops, that's okay, that doesn't seem too bad. Okay, that looks a bit more, that looks better for sure. And yeah, that's good. Because the light, I guess, will reflect off his back like that. And so his wing will be like that. His other wing will be like that. I don't know, this is a baseline, I guess. We can change this later. But it's a lot better than it was yesterday. Or whenever it was. I guess last Friday. Alright. That's not bad. That's an improvement, I think. So we're gonna save that. My sound's a little low. Okay. Let's see what I can do. Maybe that's better? I don't... yeah. Well, I can try to speak louder too. The game was down a little bit, I think. I can also try... I don't know if this is going to affect anything, but if I try and put my volume at 200%, I don't know if it can go higher than 100%, but I'm at 200 now. So I'll just speak up louder as well. Okay, that's good, I guess. Okay, so you're saying that's good. I guess I can be 200% loud then. Interesting. Okay, so next step is the octopus. Which, obviously, this thing looks kind of like an Octorok from Zelda, because that's the only octopus I know how to draw. So, let's try and make it out of pixels instead of whatever this is. It's a little anti-aliased, I guess, is what you say. So, let's remove the transparent pixels. And for that, probably it's just best to just start over. Like just use that as an outline. So can maybe have his mouth like that. And actually, let's get a reference picture of an octopus. Let's see. Come on, Google. Not actually Google. I don't use Google. I use DuckDuckGo. Interesting. I need a good picture of an octopus. I mean, this is kind of a cool one, but I don't know if it's going to help me. Well, I mean, I guess an octopus shoots ink, but how does it shoot ink? This is a pretty good picture. It's not a photograph, but this is a pretty good picture. A reference picture at least. But I guess an octopus shoots ink out of its tentacles, right? Or here we go. Here's where I embarrass myself in front of all the octopus knowledgeable people. It's like, let's see. I'm going to Wikipedia for this. And we're going to Control F ink so I don't waste time. The ink sac of an octopus is located under the digestive gland. A gland attached to the sac produces the ink and the sac stores it. Discharging ink. I want to maybe get a picture of an octopus shooting ink out. I don't know. Well, I guess my animator can deal with that. So actually, let's just copy this and use that as the background. My animator's gonna deal with the shooting of the ink. I just gotta put this into a base sprite. We need more zoology experts here. Actually, let's expand the canvas a little bit. 256. 256. This guy might need a little bit more room. That's interesting. Yeah, that thing in the chat's interesting. Let's see. It's a shame because my chat plugin isn't working anymore, which is really messes me up. Oh, there it is. Oh, boy, that's weird. So it works on that screen, but it doesn't work on that screen. Why would that be the case? Let me try and fix this. Oops. Okay, let me just remove it and then add it back in. There we go. It's back. And let's do it again over here. Okay. Well, that solves that problem. Yeah, so I guess you found the I guess you found the octopus emoji. I didn't know we had one. It's funny. Squid. I'm posting that again. That was pretty funny. uh, okay. All right. So, um, Bob Ross getting attacked by a blue squid. All right. So we will continue on with this real quick. Oh no, I'm tracing. Well, I don't know. I don't know what else to do. I guess we can actually make this smaller then, because this is, let's see, tracing on a live stream. Okay, so this would be a tiny octopus though. Let's just do 50%, and then I can sort of mess around with this. So okay, so he's got big eyes, and then he's got a head, and then he's got another big eye, and then he's got 1, 2, 3. Okay, that's bad. 3, 4, 5, 6, 7, and 8. So there we go. That's what we get when I don't trace. Now let's just do that. And there we go. Now we've got our octopus. And it looks like a total mess still. It's not that bad. And maybe we can add some shading or something. I don't know. Just make this a bit darker. And yeah, it's pretty good. That almost looks too good. And now it's gone because I undid it. Like I know they have all the little things on their tentacles, but I can't really draw all of them. Like I think that's pretty good for shading. I don't know. Their eyes kind of pop out like that, right? Okay, so their eyes are actually like inside. Like the rest of their head goes over their eyes. So yeah, so I need to fix that. So that should be like that. That's interesting. I think that eye is a little off, but I think it should probably be up a little bit. Yeah, I think that's better. But I mean, I don't know. I don't know how much detail I want to go into on this. It just looks better than whatever I had before. Yeah, it's pretty good. Okay, so we'll just go with that. Okay, so now we've got our... Well, actually, I want to do one more. real quick. So let's head back here. But instead of octopus, we're going to do the fish. Because we didn't actually have a fish sprite before. So it's just going to be a regular fish, I guess. So it doesn't have to be that complicated looking. That definitely seems like it has a Nintendo-ish feel to it already. Let's see. Yeah. I don't know. That's all I can come up with. So maybe let's do this. Make it a bit darker around the spots. It needs fins, that's right, it needs fins. Otherwise it won't get very far, I guess. So we'll do fins. It's funny, this reminds me of the Patreon logo. Which, by the way, we have a Patreon. So like, there we go. Hey, look, it's Patreon. Right. Something like that. Anyway, so feel free to donate if you want access to our Patreon stuff. But this guy needs a fin, so let's give him a fin. The outline should probably not be black either, but I'm not good at this, so we're just gonna go with black. Now that's actually kind of cool because his orange spot is underneath his fin, which looks pretty interesting. Okay, so that's our fish for right now, at least. Actually, I kind of just want to add like maybe some teeth. I don't know. I was thinking some teeth would be good. Like I don't know. Yeah, that's better. Okay, so we'll just go with that for right now. That's our fish. All right. Let me just clean this up and then we'll get started on the level. Okay, so last time we had our... Let me just remind everybody what we did last time. Well, really quickly anyway, I will. And then we'll just dive into, no pun intended, the next level. So, bam, there's this guy. And he's trying to move forward, but I think we can knock him over. Uh-oh. That's a problem we're gonna have to fix. Yeah, you have to like hit him really hard in the head, I think. Well, now it's different because his sprite is different. So, okay, he flipped himself over. But it is different because his sprite is different now. It was easier to do it before. Uh-oh. But yeah, we had made the penguin, and if I can get over here, I think the boat's over here. Yeah. Okay, the boat just kind of fell into the water. That's not good. Why is the boat so far away? Okay. And this guy... Yeah, his box needs to be a little bit smaller now. Oops. And probably his mass needs to be a bit smaller too, so we can knock him over. Say, at least he picks himself up though. Yeah, I think that sprite could still use some cleaning up. I think... Yeah, I'm not sure what to think of that right now. It needs more shading for sure. We kind of need to figure out our art style for this. What the heck is with the... It literally worked last time and now it doesn't work. It's like those switches. There we go. Right, so this is our boat, and well, right now it's sinking. It wasn't doing this before. You can check yesterday's stream, and it was not doing this. Or actually, well, Friday's stream. Anyway, it doesn't matter. I want to move on to the next level, and we'll come back and fix this later. So what I want to do is I want to grab not this one, probably this one. Maybe. Actually, I probably want to grab this one. Just because it's the most similar level. So we'll grab this level and we'll make it level 10. And then we'll have to change all of this, but that's okay. So we'll change this to glacier terrain. And that's actually kind of cool. I didn't think about that. I could actually just change the color of that. That's actually a cool idea. Yeah, that's what we've been missing this whole time. It's changing the colors like that. I miss that. So what we're going to do is we're going to make the next level, or the next, well, yeah, the next level, but also the final level of the second world. And So I guess at this rate, each world has had 5 levels in it, which is not bad. But this is going to be the final level, which means it's the stronghold, which is like our version of a castle. So the name of this one is the Submerged Stronghold, because it is going to be partially submerged in water. And you're going to have to activate switches to submerge and desubmerge all the water. Basically, it's going to have puzzles in it because I like puzzles. So we're going to actually, what we're going to do, hopefully that's not showing my desktop. Okay. We're going to, we got some switches right here. I'll move over here. So we got some switches that my artist friend drew up the other day, and it's nothing complicated looking, but I might as well do the coding for them right now. So we've got, I mean, really, I don't even need these two because I can just flip them around. So this is really all I need. And really, I don't even need that one because I can just change the color. So really, all I need is this one. But we'll go with this. I think that's all I need. So documents, save it. Let's save this in our folder. Sprites. This is going to be called switch.ping. So now we can head back in here, and I'm going to grab switch.ping, and we're going to say scale is -2, and it's really hard to see. But the idea is, well, let me see. Okay, that's better. Yeah, I think I want to add some brightness to this thing. It's too dark, I think. That's better. So now we can actually see it. And we're going to, well, what I actually want to do is I want to rotate it. But I don't want to actually rotate it. I want to rotate just the sprite. And so for that, we're actually going to need to be a little bit clever with this. So we're going to make a sprite, a child sprite, drag this onto that, actually just copy it and then remove it and then paste it. And now we've got that, but the box collider is going to be like that, so you can hit it like that, but then we want to show it like a certain way. We want to show it like this, I think. But we'll move it, well, we'll do it this way. We'll move it, yeah. Move it like that. And then we want to put it behind everything, so let's make it like that. Oh, I know. We need it in the background layer. So we can do it like that, and then we can move the switch backwards a little bit. And then, so as long as we hit this little, we hit the square here, then that will change. So it's going to take some time to actually get this thing to like move up whenever we hit it. But it's possible. So luckily though, this actually has its own script on it. So anyway, so what happens if we try and just do this? Does that do what we want it to do? So at negative 45, it's like that in starting position. Then we do that, and it's suddenly regular 45, positive 45. So that's actually not that bad. So all you have to do is make a function that switches it from 45 to negative 45 and backwards. So we can just open this up. And we know that we're going to be calling on impact. So this part of the code is just going to affect the objects, and this part is going to rotate the sprite. So we're going to have a bool, and we're going to, let's see, how do I want to do this? We'll say rotating up and private bool rotating down. And we'll have to make an update function, and we'll say if we're rotating up, then we'll do something, and else if rotating down, we'll do something else, which obviously we're going to rotate down. So we're going to do transform dot, well, actually, we're not going to do that. We're going to do, we'll need to get a private sprite renderer, SPR, and in the start function, we're going to get that. So start, and then we're going to do SPR equals this dot GameObject dot, well, actually, transform dot find, and we want to find sprite dot component sprite renderer. So that'll get us the sprite that we just detached. And then what we'll do is we'll say, wait, we don't need the sprite. We just need the transform. What am I doing? We don't need the sprite. We just need the transform. So, I mean, yeah, I don't think we're going to do anything with the sprite. I'm so used to getting the sprites though. So we'll do private transform lever. So lever, we'll just, yeah, that's even simpler. So we'll do lever dot transform dot position, which really we don't even need to do that. Lever dot position, but we're not doing position, we're doing rotation. So lever dot rotation is going to equal new, well, we're not going to do anything new. We're going to say quaternion dot lerp. So a quaternion is a really complicated thing that I don't know a whole lot about, but all I know is that it deals with rotations. It's basically the unit for rotation. So a vector 3 deals with position, and it also deals with scales, but a quaternion is what you use for rotation. So we got A and B, and so we want to lerp from point A to point B with a time of t. So lever.rotation is where we are right now, and we want to end up at hold on, I might need to look this one up. This always gets me. Let's see. You rotate. How do I rotate an object a certain number of degrees? Yeah, okay, so there's the transform.rotate function. I don't know. I've done this before in a different game. I'm just going to look up and see how I did it back then. So place your bets and we'll see how we actually do this. Quaternion dot angle axis. Apparently that's it. So we'll do quaternion dot angle axis. So we'll do a second check here. If we're rotating up and the lever dot rotation is not equal to dot z specifically, or dot Euler angles, yeah, dot z is not equal to negative 45, or we should say greater than, because we're going from 45 to 0 to negative 45, which means whatever we're going to do is, wherever we're coming from is going to be greater than negative 45. So as long as that's true, we actually don't want to do it there. So we'll do our check here to see if we should still be spinning. And if we're not, then we can say rotating up equals false. And we'll do the same check down below, basically, but for the other direction. So angle axis, this is complicated, but let's do we have to reference the current angle that we're at plus time dot delta time times the speed that we want to go at. So let's just say 2. But it's also times the angles per second. So let's just do like 360. I don't know. Well, let's do 45. I don't know what that's going to yield. But then vector 3 dot axis, the axis that we want to rotate it around, which I can't think off the top of my head which axis that's actually going to be. If we go back here, we can kind of see, I think, if it's 3D, you can see. So you can see up here, you have all these axes. So if we want to rotate it so that it goes, I guess it's about the z-axis, right? Well, see, you want to see which one is staying still. So the one that's staying still is the z-axis, yeah. Because z is blue. And you can see that the one that's staying still is blue. So I guess that's going to be it. The only issue is I think this is vector 3 dot forward. So that's going to be our code for that. And then we'll just duplicate that there and say if it's less than 45, then we can just do the same thing. But instead of forward, we're going backward. Actually, wait. Will that work? I don't know. We'll try it. And actually, let's just, for right now, let's just make these public so I can test them. So let's just test this out and see how it works. See if it works. Perfect. Okay, well, okay, except it doesn't stop, but I mean, it's rotating. What about the other way? Alright, so this one doesn't work at all, but this one works too much. How's it rotating? It's rotating, yeah, it's doing the right thing. Okay. So what's going on here exactly? Well, I guess that this is the same issue that we had last time, which is that because everything is a circle, it's both greater than -45 and less than -45 at the same time. Or maybe it's because, well, let's see. Let's just output log it and see if it's ever, ever less than -45. So, yeah. Okay. So see, it goes from 0 to 360, so that's the problem. So -45 is 360 minus 45, which is going to be 315. So if it's less than, yeah, if it's less than 315, then do that. But if it's, no, if it's greater than 315, yeah. Because if it's between 0 to 315, then do that, and then stop at 315. Or go the other way, from 0 to 45. So now just check that box, and it does not work. Now why doesn't it work? Because it's at 315. So it's at 315. It's not greater than 315. So it stops. What about this one? Here, let's get rid of the else if. Well, I think it's because we're doing vector 3 dot back. We'll just subtract it instead of doing that. We'll rotate it about the forward axis, but we'll subtract it instead of adding it. This stuff always kind of confuses me. It's not the easiest thing to wrap your head around. So okay, so now it's just not working at all. Right, so 315 is definitely greater than 45. I see what the issue is. But man, okay, that's interesting. That's tough. Because I want to rotate from -45 to +45, which is basically I want to rotate it from 315 all the way back to 45. So that's really How do I do that exactly? Debug.log lever.rotation. Okay, so, well, we know what that's going to be. So it's at 315. And when it's at 315, we want to rotate it down. So when it's at 315, we want it to go. My only instinct is to add a different variable that we can keep track of, and just, for as long as that variable is like it, then we'll just do that. So we'll do, I don't know. I'll make it public so that we can see it. So public float, I just call it number. That's bad. It's bad, but I think it'll work. So we'll say the number is -45. And then we will add to the number time.delta time plus 45.0f. And then we'll just say if number is greater than 0, then we've reached our goal. I don't know exactly if that's going to work, because we're passing that stuff into a function, and that might change it around, but we might get something out of this. I think it went the wrong way. Yeah, it went from 45 to 90, which is wrong. So let's... I just switched the minus sign to a plus sign. So then it should go from 45 to 0. Yeah, it went from 45 to 0. But what we want to do is 45 to -45. So we're just going to do that twice, basically. So if we're rotating down, then the number should be... So rotating down means go from 45 to -45. So that means if number is less than 45, do that. And we'll just duplicate this as well over here. If it's greater than 45, then we'll just do that. And we'll put the subtraction on that one. So I think I've got my numbers sorted out this time. Where'd it go? Okay. So we'll rotate down. No, it didn't work. What the heck? Why doesn't it start? Number plus equals time.delta time. Oh, duh. If it's greater than -45 and its inequality had to be opposite. Okay. I'm not exactly the best with working in 3D environments, I guess. At least not yet, anyway. Okay, well, that's different. Okay, this number is really big now. What is going on with it? Oh, I didn't realize we had that checked at the start. So it's going like that and then like that. Yeah, that's clearly wrong. Well, wait, why are we rotating up? That doesn't make any sense. We shouldn't be rotating up. We want to rotate down because it's up right there. It was doing exactly what it should have done, actually. But now it's not stopping. So why does it not stop? It's because I switched the inequalities, isn't it? We'll get this sorted out soon. I just wish that the Unity editor didn't take so long to load up. So what's the issue? The issue is that negative 45, it's not even moving. So when I click rotate down, it's not even moving. That must be because it's less than negative 45 because we're adding something to a negative, right? So it must be greater than negative 45, which is why we want it to move. Okay, so let's just do this one step at a time. If we're adding a positive number to a negative number, then it's going to be greater than what it was before. So that should be what happens. But now it keeps going. It shouldn't be going that high, but it is. So why does it not stop? Maybe I should do else if number is, that doesn't make any sense. Okay, we need to change, well, I guess we'll just check to see if number is greater than 45. We'll just hard code it like that. Otherwise, I don't know what we're supposed to do. Okay, yeah. That's weird though. I guess those are different things. If number is greater than 45, do false, else, see, this is probably what I should have done. Else we do that. See if this works. Because if that works, then I'll understand why we took so long to figure this out. Okay, well, we missed it, but it worked. So now what we'll do is we'll just copy and paste all this stuff and reverse everything. So we'll switch this out for rotating up, and we'll switch this out for a minus sign, and we'll switch this out for a Well, this also has to be a minus sign. If number is less than 45. Yeah, negative 45. There we go. So we'll see if this works. So let's uncheck that box. And actually, 1 second. At the beginning, I want it so that the number is going to equal to the lever dot rotation dot Euler angles dot z. So that way we don't need to set it manually every time. Right, so right now it's at 315 degrees. So if we can rotate down, or can we? Object reference not set. Yeah, that's not good. 19. What? Oh, it must be for some other ones. Yeah. But see, now we're stuck at that thing again where it's 315. So I could just do a simple thing right here. If number is less than, well, because the whole point of doing this was that I needed to go from negative 45 to 0 to 45, which is 315 to 0 to 45. So we could say if the number is greater than 315, well, if the number is less than negative 45, what does that mean? It means it's going below 315. So you could say, see, that's the problem though. So we'll just say if number is equal to 315, then we'll just set it equal to negative 45. Because that's the easiest thing to do, and it might cause some issues but in the future, but I'm not going to worry about that. I'll worry about it when it becomes a problem. Because the only two positions that you can ever really imagine us running into is this and the other one. Like, maybe if it was like some other way, like, yeah, I could imagine maybe, but we'll deal with that later. So it works for right now. So now we got a switch, we can go up and down. So this switch can go up and down, and we can make it bigger if we really want to. That might be a better idea. But we want the collider to be big as well. So we got negative 4 and 4. Let's offset the collider a little bit so it's like that. Or should we just keep the collider with the sprite? Why shouldn't we keep the collider with the sprite, I guess? I mean, I guess in retrospect, it's better if the switch is kind of like that. Okay, here, I'll just grab that. And we'll get rid of that. That was completely pointless. Okay. And then what I can do is I can just go back into the script here, and I can, instead of, yeah, lever is just our own transform now. There's no point to that. there's no point to making that a second object. Because it does make sense for the collider box to move with it. So anyway. But actually, we're not quite done yet because we need to make it do that whenever Snowball bumps into it. So yeah. So now on impact, if we head back into our on impact function, we're going to check if number is greater than or equal to 45. We're going to say rotating down equals true. Else, if number is less than or equal to negative 45, rotating up equals true. And then if we're rotating up and it's less than negative 45, wait a minute, I think I got these mixed up. Yeah, I got those mixed up. I think. Yeah. Alright. So this ought to work. So whenever we collide with the thing, it should work. Yep. A little too slow maybe, but yeah, it worked. So we can head back in here and we can multiply this by like, I don't know, what's 180? Yeah, 45 times 4 is 180. So we can just do that. And then we can head back in here. And also what I want to do is thin this out. Not that, like that. There we go. So the box collider is more narrow. It really should be 0.25 just because it's a more round number. But yeah. So hit this, bam, and wow, that flew out of that was pretty crazy. Okay, but I understand why that is. I think it's because of all the stuff I'm doing with this. So that's right, because I modified this number. So what we're gonna have to do is we're gonna say private float speed equals 180.0f. So we'll just speed all of these things. Replace that number with speed. There we go. And probably at this point, what I'm actually thinking is that we don't need to store that number as a separate variable. Well, we kind of do though, because I just forced it to negative 45. I don't know. I don't think it needs to be a separate variable. There's got to be a way to do that that doesn't involve that convoluted mess, but I don't know. That's the best I could think of. So anyway, we got our new and improved switches now. We just need to replace them everywhere, but I'm not going to do that just yet. What I will do though is get rid of all these enemies so we can start fresh with this level. And the reason I want to start with this one is just because it sort of has the narrow walkways that I want and it has all the switches and all that. So we'll get rid of all the sunny spots as well. But what I want to do is make it so that we can activate some switches to raise and lower the water levels. So we'll call this water, and we'll just put this stuff like right here. And okay. So I'll call this water, and do I have a prefab for water? Or do I have to make one now? Okay, I don't have a prefab for the water, so we'll go and grab it from one of these levels. Probably, which one was the rising water level? It was this one. So, drag that into there, get our prefab, there we go. Okay. And so this one just had a path, and it went up on the path. so don't save. That doesn't matter. Okay, so now we can, whoops. Actually, I don't know why I've had water. There's only going to be one thing of water. It's not like there'll be a bunch of waters now. So our water is down here. So let's modify a few things. Let's first put snowball like over this way. And then let's put the switch over here, I guess. And this is just for testing for right now, before we get into actually designing the level. So this might take until next time. But I haven't had a whole lot of time lately to work on this as much as I had been in the past, but that's okay because it's all for a good reason. So the whole point is to raise money for the business, so as long as I'm doing that, then it's all worth it. So anyway, we're gonna hit that switch and then it's gonna raise the water level. And let's move our camera this way. Right. Now, there's one other thing that we need to do, which is that I want it to raise the water to the height of the switch that we hit it at. So for that, we're going to need to modify whatever functions we're dealing with again. So let's see. Get rid of that thing. And maybe just for the time being, change the directional light. Oop. Nice work getting that switch working. Yep. A little bit late to the chat, but I've been mostly paying attention to the game. All right, I'll probably mess with the lighting later. It really doesn't matter. But so the water is like this. Okay, well, actually, I don't know. We need to come up with a water sprite as well. So, like, let's grab this for a second. And let's go in here. So, like, this is obviously not water. We could try to make it look like water. But it looks like it's a bunch of cracks in it. So, anyway, and yeah, I need to save this as a different thing. So we'll just do water. Like, I don't know. It's like anything else. So let's go back here and we'll just use this water sprite. Okay. Simple enough. And that way the color of it can be white. Anyway, so what we want is that the water is actually going to get to that height. And so the box collider, right, that's all good. Maybe the should be up like that. But, or maybe a little bit lower. I guess we're back to where we started. It's the scale that we need to increase, the X scale, so that it covers the whole level. So we'll probably make it like really big, like that, just to be on the safe side. And the Y position will be down here. And we can sort of tease at this by showing the water level right there and being like, oh, it's down there, you know. Like, okay, so there's some water down there. We know there's water down there. And there's a switch right there. And actually, we could just bring this closer, even closer. And let's bring Snowball a little closer as well. And let's see. Let's see. So when we hit the switch, we want the affected object to be the water. Okay, so it's up here. Whatever. Okay. That is it, right? Yeah, that's it. So the affected object is the water. So we'll drag our water up here. And the function to call on the water will be match height, I guess. That's the best way to describe what we want to do. We want to match the height. So this water is not going to follow a path. This water is going to be, we'll just call it rising water. Well, I don't know. I don't know if that's a good idea either. Should I just call it water? I'm trying to be descriptive with all the script names. I mean, what's the difference between water and rising water? I don't know. I'll just call it rising water. Because maybe there's some other type of water that we want to do in the future. I don't know. But it's water and it will rise, so it's close enough. And then the message that we're going to send is public void match height. So the problem is, it would be very simple if we could just pass in some values and then just match the height of that. So if we wanted to say, for example, match height vector 3, or yeah, even as simple as int y, you just need an integer and we match the height of that. So this is what we would need to do. We would need to say private vector 3 target position, and in our update function we would just have, we check for a bool to see if we're rising or not, and then if we are rising, then we're just going to do transform.position equals mathf, or vector 3 dot, yeah, vector 3 dot lerp transform.position to target position, and yeah, time dot delta time, probably times 100 just to be on the safe side, because it won't go very fast unless we do that. And actually, we don't want to lerp. We want to do move towards. We want to do, yeah, mathf dot move towards. Yeah, okay. So here's what we want to do. We want to do, we just want these y values. We'll say float y equals that, and then we'll just say transform dot position equals new vector 3 transform dot position dot x, the new y, and then transform dot position dot z. Because we want to do move towards, because lerping is kind of dangerous if you don't know what you're doing, and we don't need to lerp basically. So this is all well and good, and then we can just do match height rising equals true, and then we can just do really, again, we don't need this. We just need private int target height, right? And then we can just do that, and that works. And then we just say if transform.position.y equals the new y, then we just say rising equals false. And that could be dangerous, so let's do like, let's just cast it to an int, just so, because if you're dealing with floating point numbers, this statement might not ever happen. So if you cast it to an integer, then it should be fine, especially if we cast both of them to an integer. So anyway, match height, like, this is all well and good, and we set target height equal to y, but the problem is, how are we going to pass in the value of y through the send message function, basically? Because we're sending a message, and I've used this function a number of times, but I don't know, there's got to be a way to pass parameters, though. See, object value, it's like, well, but how do I differentiate which one of these we're going to call? You know, like, do I need to make like a different switch script entirely that just has these things on it? Well, I guess here's what we could do. We could do a switch object with parameters. Switch object complex, and we'll do string function call and public string. Well, I don't know about that though. This is complicated because now I don't I don't know what to do right now exactly, because there's so many different ways we could do this. I want to send the message with the parameters, but I don't, like, how am I going to know what the parameters are? I mean, this could be a lot simpler if we just did, like, if we just made a special switch instead of trying to worry about sending an argument with a parameter in it. So I'm reading some possible solutions to this, and it seems like you can send an array of data through send message. As long as it's an object, basically. But again, I don't know if that's actually the best idea. Because again, what kind of, like, what type are we going to be dealing with right here? Is it going to be an integer? Or is it going to be a bool? Or is it going to be... Unless we send the type as a parameter, like, that's about the only way you could do it. Or you always send it as a string, and then you convert it from that. I mean, that could work. So we'll just do public string parameter. And I guess, well, is a string an object, I guess? Maybe that would work. We'll see if it compiles. It seems like it's compiled. So it appears to work. So the only thing we need to do then is we're going to have a new array of things called switch object complex affected complex objects, and I wonder what happens if you just send a parameter to a function that doesn't take any. I guess we can try and find that out. But yeah, so we'll just duplicate this for each loop, and then we'll say affected complex objects and call the function on impact with yeah, well, it does that already. Okay, so it will just call that function, and then when we head back in here, instead of a integer y, we'll say string y, and then we'll say int new y equals y dot, let's see, convert. Yeah, I think we'll need that one. So we'll have to use system.convert. So convert dot to int 32 y. And so that way we'll get an integer out of that. Pretty sure that's going to work. And then we'll get everything. So can I convert string it? Okay, yeah. So what's the other way around? We can't use convert. We have to do, let's see, what's it called? I think it's called parse int or something like that. Oh, I know what it is. Int dot try parse y. Yeah, that's it. No overload method for try parse takes one argument. What's that? Oh, it takes out result. Okay. Okay, so that's kind of how we have to do this, I think. Oh, we need to specify. Do we need to do that? Yeah, we do. This is just syntax errors. It's nothing annoying. So can I convert switch complex to switch object? Okay, yeah. That's another syntax error. Whoops. I copied and pasted too fast. So we just do that, and then, hey, there we go. Okay. So the last thing we need to do before we can test this out is we need to assign the parameter in the switch itself. So we go back down here, and we have affected complex objects. This should be size 0 now. We can drag our water up here. Function to call is match height, and the parameter is the parameter that we're going to pass is the height of the switch, which is going to be, well, 14.5. Well, that's not an integer, so let's go back into our code. But it doesn't need to be an integer, forget that. let's just say 14. Let's just say 14 for right now. And so the idea is that when we hit the switch, it's going to look at our water object and call its function that is match height and pass in the parameter 14. And when it does this, the water is going to rise up until it hits a y value of 14, because right now it's at a y value of -11, or even lower than that, even -12. So it'll go up until it hits 14. And as soon as it does hit 14, it will stop. Or at least that is what should happen. So without further ado, I guess we can test it out and see if it works. It'd be kind of nice if it did. It's doing something. That's pretty funny. It's going too far. What the heck? I mean, it's rising. It's calling the function, so that's a good sign. But I thought that would have been the hard part. But the hard part is getting this thing to rise to the right level, I guess. So let's just output what's going on. I just want to see what's happening. Because it seems like we hit it and then it stops. Like it immediately jumps and then it stops. Yeah, there seems like they're roughly equal. Maybe reduce the time to delta time. I don't know. I would have thought I'd need that to be pretty large, but maybe not. Maybe it's because the distance between them is so small that multiplying it by such a large number is actually bad. No, I don't know. Why are they identical? That's really weird. Okay, so it's definitely 14, and then this is definitely -12, and then that's 14, and that's -12, but then that's suddenly -11. Right. So why does that happen? That doesn't make any sense at all. Well, yeah, target height, so I guess I'm trying to get the y value that we're supposed to be at next. Transform.position.y, target height, time.delta time times 10, do 60 maybe. So we'll be target Y. So the target is where we're supposed to go. Transform is where we already are. Oh, stupid me. All right, so we want to, the stop condition needs to be the target height, not, okay. Okay, there we go. Because we want to stop when the transform.y reaches the target height. Okay. We nearly had it work entirely correctly on the first try. If I hadn't messed that part up, it would have definitely worked. See, look how fast it did that. Now, it actually went a little bit further than it should have, I think. And it definitely went way too fast, so let's bring that back down. But if we go to water and go to 14. Oh, I bet I know what the deal is. It's because of its local position. Yeah, water's height of 14 is all the way up there, but see, the switch is attached to the moving platform still, so if we do that, then suddenly, and it's also attached to the platforms. Well, I don't know. That's weird though. Why is 14 so high up? Well, either way, I can sort of manipulate it to be where I want it to be anyway. Water should be like way in the background layer. Okay, so it should be like that, and then we can do. Well, we should definitely make this like a lot bigger. Okay, and so really we want it to go up to like, I don't know, just for the fun of it, we'll do like negative 29. That's really weird. Maybe it has to do with the scale. Yeah, it has everything to do with the scale. Okay, that's important to know. So let's not change the scale when we do this. So we'll go from whatever this thing is, negative 43. See, now this is negative 43. We'll go from negative 43 to negative 29. And I'll just put, that's not the right number. We'll put it right there, negative 29. And then we'll try this out, and it should work. So it will raise the water level to the height where we want it to be. Can you step the formula to raise water? I don't know what that means. Like step on the switch? So that worked, see. Okay, well here's the thing, like, this is probably the last thing we'll do. So like, I want it so that, like flipping the switch, well, I don't know. Because obviously we're not doing anything right now, but that makes sense because we want the switch to flip. Whenever the switch flips, we want the water level to rise to that level, so it shouldn't do anything right now. What we need to do is add a second switch. So that's kind of interesting. I don't know. Or maybe we could leave it as is right now. I'm not sure what to do with that. Maybe I'll need to think about it. But because if it does depend on more than one switch being present, then that's going to complicate things. But anyway, that's the basic idea of this level. So we kind of just programmed that. I mean, it was kind of interesting to do. No, just slower, but that looked great just now. Okay. I mean, it can rise up slower if that's what you're asking. I can make it go slower, like when it rises up. Like we can do, it can be about half as slow. So if we hit it, and then it'll rise up, and that's not that bad. But then I can add another switch. I don't know. I think it should be a little bit faster than that, like 8 maybe instead of 4. But we can add a second switch maybe. What are we gonna do with it though? We could put it like down here, for example, to lower the water level again. Could do that. Oops. Yeah, that's right. So could do that, and then this thing will lower it down to like, what was it, like -43. So you can try that out, and it should work. So we rise up, and that gets us over here. Oh, but the issue, darn it, we're not going to be able to get down there, are we? And we're not, because of the buoyancy. We're not going to be able to get down there unless we try really hard. Oh, but then we hit it again by accident. Okay. But yeah. So, well, my thought was that if you knock one switch down, or if you flip one switch over, then the rest of them also flip, so that there's only one that's ever like up. I don't know if that makes any sense, or whether that would be a good thing to do. But that's kind of what I was thinking. Anyway, we don't have much time left, so even though we've got, we barely just got started with this. I mean, we made some sprites, and we made, we got this thing started. We got the switches and all that working. But the goal is obviously to raise the water level and make a bunch of puzzles out of that. I don't really know if we can do much else tonight, though. So let me add a bubble. And by bubble, I meant like a bubble generator. Man, I guess I was lazy these past few days. I didn't make a bubble generator. Actually, let's get rid of that, but then let's save the scene, because I'm not sure I saved that scene. Okay. Yeah, like, oh, there's our octopus, by the way. He looks pretty good, actually. Let's play this for a second. I want to see the octopus. Yeah, so that could be better, and yeah, that could be a little bit better. But hopefully he can swim inside of the water as well. Let's see, where's the one that I want? I want the generator. Call this the bubble generator. And we'll make this a prefab. Because it worked. It worked really well. And then we can go and back here. save, and just drag and drop a bubble generator. So it's like, oh, I can't get to the bubbles up here. I mean, you can if you jump, but let's pretend that you can't. Let's pretend that that's like way too high for you to reach. Well, then you can just do this, and then you'll float up, and then you can go like that, get your bubble. Or not, because the variable bubble shield of snowball has not been assigned, so I can't get it. But if I did, then I would have my bubble, and then I would be able to go down here. Let me jump back into that one scene. Is this one. And the bubble shield, okay, so let's just drag that back in there. And we'll give Snowball his bubble shield. So I just want to see this in action. And there we go. Watch, it's not going to work again. Yeah, I knew that was going to happen. Okay, so I need to drag and drop that right there. But we're going to hit the switch, and then we're going to float up to the top, and then from there we can jump up here, grab a bubble, and then go underwater to our heart's content. And then we can hit this switch, and then bam. Now we lower the water level, and it doesn't really do us any good, but it shows proof of concept, at least, that it works. So that's weird though. I don't understand. Okay, well, I do understand. The thing, the line doesn't show right, and I understand why that is. But anyway, because when you're underwater, you propel yourself further when you're a bubble, but if you propel yourself out of water, then your gravity is going to change. Anyway, we've got a ways to go with this level, and we're just about out of time for tonight. So if you're interested in seeing the rest of this, we're going to be doing it again tomorrow night, same time, same place. So yeah, thanks for watching, everybody. We'll be back tomorrow with the rest of this level, and we're going to finish it up after finally getting all of this done, the switches, the water level, the bubbles, and we're going to have a really, really cool final water level to go through. So until tomorrow, see you then.